Hi, everyone. It's an honor to be here today. Thank you for taking some of your valuable time to come and listen to me speak. I've already rehearsed what I'm going to say so many times, I'm tired of hearing myself. I came to work first for Azomite in 2009 after being a customer for 7 years. They didn't realize I was a customer. I was a small grower up in the Santa Cruz Mountains of unique specialty crops in probably the worst conditions that you could ever try to farm something. But I found that by adding azomite minerals to my compost and other things that I was trying, I found success with rare seeds and plants and trees that shouldn't have been able to grow in that climate zone. And that was my goal, to find the most expensive crops that I could sell to the top chefs in California, to be able to have a marketable little farm and try to compete with the big guys that had been in the farmers markets for years and years. So what is azomite? We talked about mycorrhizal fungi earlier, and they say that that's been around for about 400 million years, give or take. Scientists believe that there was an event that happened out in Utah about 38 and a quarter, give or take, million years ago. It was a volcanic eruption that spewed what would be molten igneous rock and other minerals from deep in the earth into a cold water body in Utah. When that happens, it creates a very unique material, which is the azomite ore. Azomite is considered a highly mineralized complex silica ore. I've added the parentheses here because hydrated is a key word when we talk about these different types of minerals as nutrients for crops. Hydrated means that when that hot molten lava was quenched into something very cold, it actually fractures the molecules and creates an amorphous, kind of widely distributed material that has little bits of volcanic glass in it. And volcanic glass is what they call kind of between a liquid and a solid. You might consider it a quasi-solid. The molecules never quite arrange and become highly condensed or crystallized. Azomite is primarily used in the U.S. Our biggest market is actually the animal feed protein market. Chicken mills have found that azomite, it's a little bit harder than the feed materials and a little bit gritty. It has a bit of abrasiveness to it. It helps the feed mills run much more efficiently, which lowers their electricity amperage. They get better throughput, better pellet quality, and then they get a host of nutritional benefits for the animals that come along with azomite. It's considered GRAS. Classification means it's generally recognized safe for animal feeds. We currently sell azomite into about 70 countries, and it's sold for all kinds of animal feeds and a lot in Asia and other parts of the world for aquaculture. It's a wonderful fish food. So that gives you confidence that if you use it in your crops and it gets out into your waterway or stream, you're going to be benefiting nature rather than hurting it. It's OMRI listed, and it's also CDFA organic input material registered here in California. So as I said, it's a volcanic origin. It was all these minerals that are now contained in this silicate base. I mentioned that it's non-crystalline, meaning crystalline minerals are very hard and the molecules are kind of laid out oftentimes in a linear structure or very compressed structure, and it makes them harder to break down or to get into the irrigation water. It's called a dacitic rhyolitic tuff breccia. There are now studies coming out around the world that these volcanic sites, certain of them that are safe to use, have very good promise for us to be able to add to our fertilizers and crops to create more sustainable growing around the world. Azomite is poorly welded, meaning all these molecules are not tightly compressed together. When the ash fell into this water body, it was not pressed down and packed very tightly, which makes it ideal for biological life. These photographs you can see are why azomite is so unique compared to some of the other what they call rock dust or glacial rock dust. They come from different origins, different locations, and they can be very different characteristics. When we talk about mycorrhizae or bacteria, what he mentioned was the hyphae, the small threads, can penetrate into something like an azomite particle very easily because it's got these little gas bubbles and pore space, and the minerals themselves are in this kind of glassy, porous silicate framework that are more easy to access. It also has a fair amount of clay particles because there was probably some weathering, there were probably some organic life forms in that water. Some of the materials in azomite are easy to access for bacteria and beneficial fungi. Like I said, our biggest market in the US is chicken production, but we are doing research in other types of animals, swine, and we do have a number of customers that feed azomite to everything from pigeons to goats to crabs. So what are the benefits in plants? In the last 20 years, a large number of research universities from around the world have taken it upon themselves to research azomite in various crops and animal science because it is basically a collection of over 70 minerals. It's considered an aluminosilicate, meaning the aluminum and silica are tightly bound together. Some people say, oh, I see alumina in this, that scares me. But nature has a way of not breaking apart very easily the alumina from the silicate. The microbes typically go after the silica after they've sought out and gone after the other beneficial elements like calcium, magnesium, boron, zinc, etc. This study was done with a group up at UC Berkeley, a company called iCultivar, and different professors. They used the greenhouses at Albany that the USDA owns, and this was done on tomatoes. Basically what they did was treated azomite tomato seedlings with granulated azomite in the pot, and then did a couple dosages of the finer material over the top in the watering cycle during the plant's life cycle. They were looking at how does azomite actually work? How does it prove itself around the world in all these different crops and all these different biological systems? In this case, they decided to look at root-associated bacteria with the plant. This study made the cover of the Journal of Applied and Environmental Microbiological Sciences, and this is basically the root showing that with azomite in the root zone, the plant was able to draw specifically different bacteria to the root, and not only to the root, the rhizosphere, which is the surface of the root, and specifically in the center of the root, what they call the core taxa, which was really significant, they believe, in the plant being able to grow better and produce better quality fruit and more fruit. This is some of the more technical data that was done during the study, but on this side here, on the left-hand side, you can see that between week 16 and week 6 and 8, and towards the end of the plant life, the different bacteria that have different functions changed greatly within the center of the root versus the control. Ultimately, the plant was able to produce better sugar, and specifically long-chain carbohydrate sugars, which happens to be the same types of sugars and carbohydrates that mycorrhizal fungi live on. So this is a symbiotically beneficial treat, more or less, for organisms when they have a copious amount of micronutrients in the root zone that the plant can draw from. What was very interesting is that during different stages of development in the plant, at flowering, at fruit set, there was more flowers initiated, less flowers that dropped, and then when the fruit ripened, there was more weight to the fruit, not specifically because there were more tomatoes, but the tomatoes were more dense and the quality was much better. They found wider leaves on the tomatoes, producing better photosynthesis. And down here at the bottom, I'll just skip through some of these. The chlorophyll content was almost double in the azomite-treated plants. This is a new study that's just now being published, and I won't really get too much into this because I've not seen the study yet. It should be published after this final review that it's going through right now. This is where they tested Arabidopsis seedlings under different types of light with nothing but pure azomite added to the dish. They found, which was unusual, was that they grew in both directions rather than just one with azomite alone. No sugar, nothing else to stimulate them. And they grew specifically better under red light and white light. What this tells them is that azomite is influencing something from the very beginning of the initiation of the seedling in beneficial ways, and it may lead to some new things in science, that the photosynthesis-related growth regulating processes are enhanced by azomite. So how does it go? Azomite is added to the root zone. Bacteria and fungi seek out and biosense where the minerals are for their host plant. The plant gives off hormonal signals looking for specific nutrients during its life cycle and environmental events. The plant then is able to photosynthesize better, produce more long chain and different amino acids and sugars that the bacteria and fungi live on, which creates a better overall nutritious environment for both. Who are we? We're a Utah-based corporation. We're very customer-centric. We are south of Salt Lake City by an hour and a half. The mine is about 20 miles south of Nephi. We have our own integrated production facilities as well as a rail siding with 35 cars and adding more. I think Jim, okay, so Jim, our president, Jim Phillips, our president, is here today. And we want to welcome him. We have our own warehouse storage, and we've just now are completing our own granulation plant, which will help us meet some of the challenges for large-scale agriculture. We've had a granulated product for the last 10 years, but it was a little bit off-size for being able to mix uniformly with fertilizers, and we'll also be able to produce high capacity of minis and other custom sizes for greens or turf and ornamentals. It's a little picture of our plant, and I want to thank you very much. It's a little snapshot of who we are. Thank you.